Welcome to all. In the previous video, that means last class, we are discussing about polar curves. In that polar curves, we are deriving one important theorem, the angle between radius vector and a tangent. In that result, we are obtaining in this form, it is tan phi. It should be equal to r into d theta by dr. So this is the one of the results we are extracting in the previous class. We can also write down this in this form also. If we take a reciprocal of this, we are getting 1 by r, that is dr by d theta. One more form for this one. So this is also called an angle between radius vector and a tangent. And also one more thing, result we are also discussing about this, how to find the angle of intersection between two curves. Okay, so that one we simply are considering that like that, it is as an absolute value of phi 1 minus phi 2 as a modulus value. If you are getting a 90 degree, the angle between two angles, we are getting phi 1 and phi 2 is 90 degree. If you are getting a 90 degree, we call it as two curves intersect orthogonally. Okay. And one more option is there. So when you are applying this one, whenever if you are going to find out the angle of intersection between two curves, by eliminating the function phi 1 phi 2 very easily, we can use this formula. So that is the formula we are used to extract the angle of intersection between two curves. Sometimes it's very difficult for extracting the angle of intersection between two curves, that means phi 1 and phi 2. It's very difficult. In that case, we can use the formula, that is tan of phi 1 minus phi 2. Just me have to apply the tan for this. I have to use this formula, that is tan of phi 1, then minus tan of phi 2, then all divided by 1 plus tan phi 1 into tan phi 2. It's an absolute value. Okay. So these are the things we are discussed in the last class. So that means the first derivation will give the angle between radius vector and the tangent. The another form of this one, we get this one. So after that, we are going to find out the angle of intersection between two curves by using the formula phi 1 and phi 2. If phi 1 and phi 2 equal to 90 degree or pi by 2, that one we call as a two curves are intersect orthogonally. And also one more formula is there, the same thing for find out the angle of intersection two curves. If phi 1 and phi 2 not getting directly, in that case we can use these formulas. If remembering all this problem, we can go into solve some problems, how to find out the angle of intersection between two curves, what happens if intersection of two curves intersect orthogonally. These are the things we are going to discuss in this class also. Okay, so before discussing of that class, we have to remember the basic properties of logarithm, properties we are using here now. Generally, you have to note this one. The properties of log m into n with a base, any base. The any base means base 10 or maybe base e. Generally, we are taking a base e. If the logarithm of m into n, that means the product of two function is there, you simply have to use this formula, that is a log m plus logarithm of en. So this is the formula, this is the product of two function. We have to make it in the form of an addition. Okay. The second case is a division form. If m by n is there now, in that case you can use the formula log m minus of log n. Use this formula. So one more is there, this power form, simply we call as in power form, log m power n. That should be, you have to write down in the n into logarithm of m. So these are the three formulas we have to remember. So I am going to solve some of the problems by using the concept of angle between radius vector and the tangent. These are the three major formulas we are used to solve the problems by using this concept. Okay, and also remember all these things. So then after that, we are going to some problems. They asked like that in the examination, show that two curves intersect orthogonally or perpendicularly. They asked like that. Okay, so I will take some of the problems. So I'm going to solve here now. show that, the short form is there now, show that, or simply you can also write on, show that the following curves, show that the following curves intersect orthogonally. They ask like that. So I am going to take a first problem now. So apart from this, I am going to first problem. It is an r times of a into 1 plus cos theta and r equal to b times of 1 minus cos theta. This is the problem they are given. They asked you show that these two curves are intersect orthogonally. Okay. So whenever if you go to evaluation of this problem, you have to remember especially these basic properties. So we are going to solve this problem at all of, I'm going to evaluation of that problem by using the basic concept. Okay. So what they ask in the problem, they asked you to show that the curves intersect orthogonally. That means orthogonally means the phi 1 and phi 2 equal to 90 degree. The extraction, we show that they are intersect orthogonally. One more option is there now, that one I can also write down here. So suppose this one we can also write down the two curves tan of phi 1 into tan of phi 2. If you are getting a minus 1, that is also shows that if two curves intersect orthogonally. Or sometimes cot phi 1, we can also use like that, cot of phi 1 into cot of phi 2. We can also show that as a minus 1. That is also valid for showing the curves are intersect orthogonally. So you have to remember all these results, then we can easily evaluate that one. Okay. Now first I am going to solve this one. So write down the solution. So first you have to preferably take a log on both sides. You have to take the log. It's very easy to evaluate this function. So if you are taking log on both sides for this, r equal to a times of 1 plus cos theta. Okay. Now taking log on both sides. If you take a log on both sides, this become log r should be equal to logarithm of a into 1 plus cos theta. Okay. So after taking a log for this problem, what happens? This relates to this theorem. The product of two functions is there now. This results. See here, the log m in place of m. See here, m into n. In place of m you have a. In place of n you have 1 plus cos theta. It's clear? Okay. Now use the properties of logarithm properties here now. So what happens if product is there, you make it a sum of the two terms. So that becomes is the log r. It should be equal to, it's a log a plus, instead of log m plus log n, then becomes a logarithm of 1 plus cos theta. You see here, m into n, it reduced to m plus n. It's clear. Okay. So then after that, you have to differentiate this one. Differentiate with respect to theta. Now I'm going to differentiate this one with respect to theta. What do we get now here? The differentiation of log r is 1 by r, that is dr by d theta. It's clear? The differentiation, this one with respect to theta. The logarithm function, your r becomes 1 by r. Then this part of r with respect to theta, they become dr by d theta. Then it should be equal to, now differentiation of any constant function, your log a is a constant function. If you are going to differentiate of that one, it becomes 0. Plus, now differentiation of same thing, the differentiation of log is, it becomes 1 by 1 plus cos theta into, inside the angle we are going to differentiate now here. The function is over. Now I am going to differentiate the angle. 1 plus cos theta is your angle. Now differentiation of 1, they become 0, constant function. Then cos theta is, differentiation of cos theta is minus sin theta with respect to theta. That is 0 minus sin theta. You have to remember now. Okay. Now 1 by r dr by d theta, you have to use this result. 1 by r dr by d theta, we have to use this result. It's a cot phi. Now simply, it's a cot phi. Now call this as 1 because 2 curve is there. So call this as an cot phi 1. Okay. It should be equal to then minus sin n theta. 1 into minus sin is 0 minus sin theta is minus sin theta. You have to remember. Minus sin theta 1 is minus sin theta, then all divided by 1 plus cos theta. So now we are getting a minus of sin theta divided by 1 plus cos theta. The same procedure we also adapt for this one also. So I have to extract the another value, that is cot phi 2. Okay. Now I am going to evaluate the other function. Now again differentiate with respect to theta. Now I am going to differentiate this one with respect to theta. Same procedure I have to adapt here now. Okay. Now it become taking a log. Sorry, before differentiation, first you have to take a log on both sides. Log on both sides. This become log r should be equal to log b into 1 minus cos theta. Okay. Then becomes log r, it should be equal to log b plus, it's a logarithm of 1 minus cos theta. Is it clear? Now I am going to differentiate this one. Differentiate with respect to theta. Now I am going to differentiate this one with respect to theta. What happens? They become 1 by r, dr by d theta should be equal to, the log b is a constant 0. Again, it is 1 minus cos theta into 0 minus of cos theta, they become plus sin theta. Okay. So again here, it related to this result, cot phi equal to 1 by r dr by d theta. You have to use here and we call as cot phi 2. Why we call cot phi 2? Because there is two curves is there. First curve I am calling as 1, the second curve I am calling as cot phi 2. So this become sin theta divided by 1 minus cos theta. So in this problem, what they ask you, you have to show intersect orthogonally. 3 option is there for showing that intersect orthogonally. So either using tan phi 1 into tan phi 2 equal to minus 1 or cot phi 1 into cot phi equal to minus 1. This is the second option. Or you can extract the cot phi 1 and cot phi 2 by using some relation of formula, trigonometric formula, then extract the values of phi 1 and phi 2. Then you have to subtract it. You can also show it is a orthogonal. Okay. So which is convenient for you, you can use it. So now I am going to show this one. So make a product of these two, equation 1 and 2. If you make a product of equation 1 and 2 and showing minus 1, they become an intersect orthogonally. Okay. So now take a product of 1 into 2. Now taking equation 1 into 2. So make a product of these two. Okay. Cot phi 1 into cot phi 2. If you take a product of that two terms. So from this side we have minus sin theta divided by 1 plus cos theta. Then another equation, sin theta divided by 1 minus cos theta. Clear? So make a simplification work. You keeping the negative term as it is here now. Now sin theta into sin theta, sin square theta, and 1 plus cos theta into 1 minus cos theta. Now use the formula of a plus b into a minus b. This is a plus b, then a minus b. Then what the result they given, a plus b into a minus b, it will give a square minus b square. Use that formula. Your a plus b, then a minus b, they become a square minus b square. They become 1 into 1, it is 1 square minus cos square theta. Okay. So now using the identities of trigonometry, so now write down 1 square minus cos square theta as a sine square. So you know that it is well familiar for everyone. It is sine square divided by 1 square is 1 minus cos square theta, then minus of sine square theta all divided by 1 minus cos square is sine square theta. Now go to cancellation of these two, we get minus 1. That is cot phi 1 into cot phi 2. Okay. This shows that hence two curves intersect orthogonally. Hence the two curves intersect orthogonally. This is the procedure we have to follow to solve this equation. Means if two curves are intersect orthogonally. Okay. So now I'm going to solve some more problems. So now I'm going to for the second problem. Same. Just you recall what we are going to solve. What way we are going to solve the previous problems. The same procedure to follow here. Okay. Now take down the solution. R power n equal to a power n cos n theta. Okay. The first procedure is now taking log on both sides. Now taking log on both sides. Okay. This become a logarithm of r power n should be equal to logarithm of a power n cos n theta. It's clear. Then apply the properties of logarithm. So what is that third power form logarithm? They given this is the formula. Log m power n should be equal to n into log m. You have to remember this. Okay. Now, if using this become n into log r should be equal to. Now here first property, you have to apply the first property, log m into n, log a power n plus logarithm of cos n theta. Here the product of two function is there, m into n, you have to use it. Okay. So one more option is there. So now n log r should be equal to, now write down this is n into log a. Okay. Again use the properties of logarithm. Plus then logarithm of cos n theta. Now, so now it is comes under the form of differentiation form. Okay, the power will be reduced. Now it is very easy for doing a differentiation work. For that, then I am going to differentiate this one with respect to theta as usual. Now differentiate with respect to theta. Okay. For the differentiation, so n is constant into function is there. Now keeping n as it is. For the differentiation of log r, this is 1 by r dr by d theta should be equal to, this is a constant function. Now n is constant, log a is also constant. Now go to differentiation of constant function. What we get now? They become 0. If we differentiate with any variable, they become 0. Plus, what about the differentiation of this one? Log is as usual 1 by cos n theta. First I differentiate the function. The differentiation of function of log is 1 by of that function. Then I have to differentiate the angle. What is the differentiation of this one? Minus sin n theta, the function. And also one more thing is there. Now differentiation of angle, they become n into 1. N is constant. Differentiation of theta with respect to theta, we get 1. Okay. Then finally, we are getting minus sine n theta by cos n theta. This one we can write down n into cot phi 1. You put in cot phi 1 because two curves is there. One curve we call as an phi 1. It should be equal to, then write down here, minus sine divided by cos is tan n theta into n. Now cancellation of these two. Now finally we get cot phi 1 is minus tan n theta. Now call this as equation number 1. Okay. The same procedure we adopt for the second equation. Now use the same procedure for the second equation. So again, r power n should be equal to b power n sine n theta. Now taking log on both sides now. Taking log on both sides. Taking log on both sides. This become n. Can I write directly? No, write down directly here. N into log r should be equal to n into log b. Just I am following this procedure of this one. Plus logarithm of sine n theta. Now differentiate this one. Differentiate with respect to theta. Now differentiate this one with respect to theta. Then n into 1 by r dr by d theta should be equal to, this is a constant function 0. Again the same procedure, differentiation of log is function cos n theta. Then differentiation of sine is, this is 1 by sine n theta. Then you get cos n theta into n. Then n into, this one we call as cos phi 2. Then cos divided by sine, this become cot n theta into n. Now cancellation of both n. Now we got cot phi 2 is cot n theta. Now you know that the procedure. If two curves are intersect orthogonally, take the product of these two. Now call this as equation number 2. If two curves are intersect orthogonally, now take the product of 1 into 2. That means equation 1 into equation 2. Now take the product of these two. What do I get now here? Cot of phi 1 into cot of phi 2. It should be equal to product of these two minus tan n theta into cot n theta. You know the trigonometric identities. Cot theta into tan theta. The value is 1. Now use that one here. Cot phi 1 into cot phi 2, it should be equal to minus 1. If you cannot understand, you can write down cot as 1 by tan or cancellation of these two, you can also getting minus 1. So then you write down hence the two curves are intersect orthogonally. Hence two curves intersect orthogonally. So this is the complete procedure to solve these type of problems, to showing two curves intersect orthogonally. Show that the curves show that the curves r square sin 2 theta equal to a square and r square cos 2 theta equal to b square intersect orthogonally. Okay. So as usual, you can use the previous method to solve the other two cases problems. The same problems you have to, the same method we have to follow here now. First you have to extract the phi 1 and phi 2. Then after that take the difference of that equal to -1. This is also showing the two curves are intersect orthogonally. Okay. Now taking log on both sides. This becomes log r square sin 2 theta then log of a square. Now use the properties of logarithm. This becomes log r square then logarithm of sin 2 theta. Then this is also 2 times of log a. Okay. Then this becomes 2 times of log r plus logarithm of sin 2 theta equal to 2 times of log a. The powers are also reduced, then you can easily differentiate the function. Differentiate with respect to theta. Now I'm going to differentiate this one with respect to theta. We get 2 times of 1 by r dr by d theta plus logarithm function that becomes sin 2 theta you written as it is. The differentiation of this one 2 times of cos 2 theta equal to 0. Then 2 times of cot phi 1 plus 2 times of cot 2 theta equal to 0. Send this function to other side. So divide by 2. Then send this function to other side. Cot phi 1 equal to minus of cot 2 theta. Or simply cot phi 1 equal to cot of minus 2 theta. Now cancellation of this one phi 1 equal to minus 2 theta. This is also another form to show the curves are intersect orthogonally. What I am doing here now, I am extracting phi 1 very easily. Next, the same procedure I have for the other one, cos squared, cos 2 theta equal to b square. Now the same procedure. Now first you take the log on both sides. Then you have to simplify this one. This becomes log r squared cos 2 theta should be equal to, it's a logarithm of b square. Log r square plus it's a logarithm of cos 2 theta should be equal to 2 times of log b. Then 2 log r plus logarithm of cos 2 theta 2 into log b. Now differentiate with respect to theta. This becomes 2 times of 1 by r dr by d theta. Now differentiation of this one 1 by cos 2 theta into minus 2 sin 2 theta should be equal to 0. This is 2 cot phi 2 plus into minus 2 tan 2 theta equal to 0. Now divide by 2 both sides. Then I have to transfer this function to other side. They become cot phi 2 equal to tan 2 theta. So now I wanted to find out the value of phi 2 by using the concept of allied angles. This become tan, we can write down as cot of 90 minus 2 theta. You can also write down like this. Okay. Now we extract these two. Then we get the phi 2 value. Now we get this one. Okay. So this is an 1 and this is called this as an equation number 2. So now what I'm going to show, the curves intersect orthogonally, just to take the difference of that two. For orthogonal, now take phi 1 absolute value of these two. Phi 1 is minus 2 theta, then absolute value of 90 minus 2 theta. Should have to take the absolute value. Minus 2 theta minus 90 plus 2 theta. Now cancellation of these two. Now you get minus 90. We are considering only the absolute value. Then easily you can write down phi 1 minus phi 2 is also 90. So this is also another way to show the curves are intersect orthogonally. We can also use the previous problem methods also by taking the product of cot phi 1 into cot phi 2. If you take the product of these two, that will also give the value of minus 1. You can also show like that. Either you can also show like this, phi 1 minus phi 2 equal to 90 degree. This is also another method to showing two curves are intersect orthogonally. Okay. So thanks for watching this video.